Now we're going to talk about what it means for two vectors to be parallel. So two vectors, two non-zero, they must be non-zero vectors, u and v, are parallel when there is some scalar c such that u equals c times v. So basically, to be parallel, one of them needs to be a scalar multiple of the other. So let's look at this a little bit more. Let's look at the following problem. So I'm going to tell you that the vector w has initial point to -1, 3 and terminal point -4, 7, 5, which of the following vectors is parallel to w? So I'm going to ask, is w parallel to the vector u, which would be 3, -4, -1? Well, we need to write the vector w first in component form. So we're going to take w, look back at w, here's my terminal point, here's my initial point, and then you're going to subtract them to get w. So -4 minus 2, 7 minus -1, so 7 plus 1, and 5 minus 3, and w is the vector -6, 8, and 2. So now let's look, and we're looking at u here, and we're looking at w. And if you look at u, can I multiply a scalar to w to get u? Well, let's look here. U is this 3, -4, -1. If I take w and multiply by -1/2, the negative will flip the sign, so it'll become positive, negative, negative, which matches up with u, and I'll get a +3, a -4, and a -1. So in the end, I was able to write u as -1/2 w. So my answer is that u is parallel to w. All right, so now I want to ask, for second part of this problem, is w parallel to the vector v, which would be 12, -16, and 4. So I can't tell how v and w would be related, if they even are. So let's just look at our equation here. We need to show that there's a scalar so that v equals c times w. If this is parallel, if v is parallel to w, our mission, our goal, is that we need to find c in this equation. Well, let's look. here. Let's plug in v, 12, negative 16, and 4. C times w, which is negative 6, 8, and 2. And let's go ahead and do the scalar multiplication on the right. Negative 6c, 8c, and 2c. Well, this equation right here says that these two vectors are equal. But remember, these two vectors are equal. The only way that's possible is if all their entries match up. So 12 has to be negative 6c, negative 16 would have to equal 8c, and 4 would have to be 2c. And let's look at these equations here and solve. So this bottom one tells me c is 2. This one tells me c would be negative 2. And this one tells me c would be negative 2. Well, c can't be 2 and negative 2 at the same time. So because I'm getting different values here, what I'm learning is that there's no solution to our equation that's up here. There's no solution to this equation up here. So basically what that means is that the vectors v and w are not parallel. All right, so let's look at one more problem using parallel. So I want to determine whether the points P, which is going to be the point 1, negative 2, 3. Q is going to be the point 2, 1, 0. And R is going to be the point 4, 7, and negative 6 are collinear. So this phrase here, collinear, what does it mean? It just means that they all lie on a straight line. So we're going to take these points and create some vectors. But some very specific ones. So let's look at PQ. So my initial point would be P and my terminal point would be Q. So let's write this down in component form. 1 minus a negative 2, 0 minus 3. I'm getting the vector 1, 3, negative 3. Now I'm going to keep the same initial point, P, but I'm going to use the other point for the terminal, R. So 4 minus 1, 7 minus a negative 2, negative 6 minus 3. I'm getting the vector 3, 9, negative 9. Now let's think about these two vectors that I have here. They involve all of my points, and if I notice, these two vectors have a common initial point. So I have P and Q, and then if I want them to be parallel, I have P. If I want them to be collinear, they all lie on a straight line. Here's PR. So I need these two vectors. If these points are collinear, then these vectors need to be parallel. So what I'm saying is that P, Q, and R lie on the same line. If and only if these two vectors, PQ and PR, are parallel. So I need to find out, are these vectors parallel? So let's look at these vectors here. Are they parallel? Take a minute and look at them. Think about it. If I multiply the first vector by 3, I will get the second vector. So PR is 3 times PQ. So the answer is that these vectors are parallel. Therefore, these points are collinear.